Welcome to Tutorial 2, your separate compilation using Make. And if you don't have experience with dealing with multiple files and compiling everything together and doing this on Linux for C++, this will be your first introduction that should follow from the actual lecture. So I am using the Tutorial 2 document that can be found on the course Blackboard page. There is nothing that's for marks for this tutorial. This is just a guided tutorial that you should go through on your own. You can read through everything and follow the steps independently in this document if you would like. Otherwise, you can also follow along with this video where I am just going to live demo the actual tutorial itself. Now, the first step you should do is to make sure that you remote into INS, and if you're doing this from home, make sure you opened up the VPN first and then opened up your connection to the INS server itself. Right now I just have it with the actual tutorial document open, and then I have two open connections to INS to allow me to do some editing in one and then do my commands in another as you follow along. Now, you should pause the video now until you are actually connected and set up and ready to go, and when you are, come back and replay the video or continue playing the video. Your first step to do is, it'd be nice just to keep everything in a directory while you do this tutorial so it doesn't actually get mixed up with everything else you're doing. So at least in your main directory, or if you've made a subdirectory called 1633 for this course, you can just make a new directory. And here we're going to step through doing some demoing. So the first part of this actual tutorial is just demoing when you have code in two different files, what happens and what messages would you see on the compiler, and how can you go about manually compiling everything and then linking it together into your executable so that the code can be shared between two files and create one program in the end. That's this first part. And that's what deal things like header files and separating files and your include. And then next, getting into what's called make files in Linux and using the make program to help you automate this process so you don't have to manually do it. So you can watch me do it manually first. I suggest maybe you type it out so you get that experience as well. And then next is setting up a make file to do it for you and starting to learn a little bit about how it works, how to set it up and change a few things in between, and be careful about what you're doing. Now, the lecture notes go into further detail, which you should also practice. So we'll go back up here to the top. The first step is to make a file called main.cpp and put this basic hello world program in there. Now I'm going to be a little lazy. I don't want to type out all this code, so I'm just going to copy it from another document that I have into here and then save it. Should see. How about I actually put it into the right directory? Okay, there we go. So the first step is we can just do a basic compilation of the main and get the most boring program you always start with programming courses with, and is your hello world. And you can see we got a working program so far. The code is okay. We've got the hello world. That's this first step right here. Next, what we're going to do is put a function into a different file and then show how to actually include that file over into the original one. Now you may be wondering, like, why are we doing this? Why are we putting it into separate files? And the point is, for your first programs, it's okay to have everything in one file and break it down because you're smaller programs. But as programs get larger and larger and larger, you don't want everything to be in one file. What if you had multiple people working on the same actual program? You can't all work on the same file at the same time. from right here, unless you're doing some code repository and sharing and stuff like that. But here in reality, you want to break it down to make your code more modular and understandable, where you're breaking it down into separate files based upon functionality or some kind of scope of your actual program. And then you're going to have to deal with, well, how do I include everything back together? So next we'll make a new file called util.cpp and put this other function in here that we're going to want to call in the top one. Once again, I am just going to copy the code over to save some time. Oops, almost forgot some stuff. Okay, almost forgot the headers and the imports. Now, what we can see as before is that we had originally this code in the main right here. We have a separate file called util.cpp with this function right here. And if we were to go back, so now we have this code. If we go back to the main and try to call that function, assuming as if it was here, we're going to start getting some errors, maybe some common ones you've seen. So we'll act as if we're going to call that function right now. Save this. Go back and recompile the main, and hit our first syntax error is that util is not declared within this actual scope. So you know these of them. You haven't declared a variable. You haven't declared the actual function itself. Well, it's screwing up. It doesn't know where it is. So now most times, you know, like if you're defining your actual functions and you don't want to have them all above the main, we'll just put a header, and normally you'd put the code below. So we could start by, say, putting in a header right now. Just don't worry, you're going to do this differently in the future. This is just to guide you through so you can get used to some error messages. But if we put the header, so your function prototype at the top, and resave this, and now go back and recompile this, we will now see a different error. Now we're not seeing anymore that that was that error that it's unknown symbol. It says right here, main undefined reference to util collection error. Now what this means is that by you putting this prototype at the top, you've kind of given a contract or said to the compiler, okay, here is the definition for how it looks to call this function, and by putting a semicolon here at the end, you're saying, okay, I will define this later, and then you can link everything properly together. So it allows it to be legally called here, but now that we've only had this code within here, and all we're doing is just compiling, just main.cpp here, that's all that we're compiling. It compiles it, tries to make the rest of the program, but it's like, hey, you haven't fulfilled defining this function here. You haven't linked or given me that somewhere. So normally, you know, you'd come down here to the bottom and you'd actually define it. So you'd be like void util like this, and you'd have your actual function. We could go back and like compile now and it should be okay. So this is fine. We've got our actual like a.out, our default name for executable, but this is still defining everything in this file right here. So what if we wanted to actually deal with putting it into a different file? So we're not defining it down here, but having a different file and telling the compiler to do that. Use that one. Now, what we could do instead is use the actual G++ -C flag to indicate compile this to what's called a .o file, which means it's not fully compiled, but it's down ready to be linked everything together. And then what we can do is for all of our files that we have separately in all our code, we can compile them to .os, and then we can link them together as a dot to make your final overall executable. So we can do this here. We now see that we have the main.cpp and util.cpp. We can first compile the main. And we can put the -c flag. If we compile this, we should now see that we have a main.o file. So this is a temporary file in between saying that the compiler has partially compiled this file and it's ready to be linked in with the rest of the program. So we have the main.o, but now we need to compile the other file. So our util.cpp. And now we will have a .o file for each of our files right here. Boom, following these steps. Now the next step, instead of separately, is to link these finally together. So now you just go G++, don't use the -c, .o. So we give it the both files here, and it's going to know that these are both partially compiled together, and now it'll link all the code together using both of these files. And we have our new a.out, which we can now actually call. And there you go. We have the original code from both of them, what we had in main. We have the second function from util, and it's in another file. So the key parts from this is, again, that we still need to have this prototype above. We still have the rest of the code here. And then we have to remember when compiling that we are doing the G++ -c with the file.cpp to say that we're getting it to a .o file. So again, our .o files that we have there and there for both the files that are partially compiled files, and then finally compiling it together, just the .o at these step here. Now, what we would want to do is now set up dealing with what's called header files. So we've got that first basic for your code here. You got the compiling, but now you wouldn't want to actually have where you're having the separate file here where you have the functions, and then having to, in every file you want to do the code, do this prototype that we had here and above. It would be nice that we could make the .cpp file that has the actual definition of the code, and then create what's called a header file to contain just the prototypes for the functions, so those can be included in other files that are going to be calling the code that you put into your .cpp file. So generally you will need this, that you'll have one file for your actual main, and then if you're splitting up code into separate files, you'll have your .cpp file with the actual code within it and the functions, and then for that same file you'll create a .h file that's called a header file, where you'll put just your actual function definitions and prototypes within there. So this is with the header files. So next what we're going to do is we're going to create that header file and then come back and replace this call that we had here where we hard-coded in the actual prototype in this one file. So now we're going to create a file called util.h that will contain the prototypes for the functions that we put into util.cpp. So you can see that create a util.h file right here. Within here, for right now, we are just going to put void util, so the prototype for the function that we have in the actual CPP file. So again, you can see there we've got this in the util.h. In the util.cpp, it's got whatever includes it needs to have right here, and then it has the util function actually defined. So our next step is to open up your main.cpp. And we're going to take out this original line we had here for the prototype and now include r.h, but going to use a different actual slight syntax for the include. Here what's important is we will have the include like we've seen before with the hash, but we do not use the actual angle brackets anymore, which defines that it's a built-in library that's installed properly for C++ in the compiler. Instead, we're including it in these double quotes, and what this means is look in the current directory where this file is actually located and include the file called util.h. So if we save this here, we can now see that we have our main.cpp, we have our util.cpp, and we've got our util.h right here. So we've got the header file for the functions that are defined in the util.cpp, and then we have main.cpp that wants to use functions that we have put into util.cpp, so we are including the .h so that it has the actual prototypes. Now what we can do is just a demo. We can go through now recompiling everything like we did before. So I am just going to remove all of the old files manually. So you can just see that we're down just to the original files that we had. Main.cpp. We get the .o. The util.cpp, get its .o, and now link the two .o files together to create our a.out like we had before. Okay, and you can see there, got the original program and everything's compiling and working properly with their .h's. So in the future, you're going to have to remember that if you're breaking up your program into separate files, that you have to remember one is make a file that's going to have your functions and define them in there. Also for that same file, create another one called the header file, so the same name, just for good conventions. These names are just up to you, so it's nice to know that you put the same name for both, just so that you know that this is the header file for the code that's within this file here. So it's just good coding convention, not actual syntax or semantics things. And so the .h will just contain all the prototypes for the functions that are here, and any other file, so not just the main, but any other file that wants to use functions that are defined inside of this file, you have to include the .h into that code there. So your main here is going to be the one that won't need a .h unless you're defining other functions that are going to be defined in a different spot. And going through the linking then of using the -c flag to actually get your .o files, and going through steps to link everything together. Now what we could also do, instead of just having the a.out, is just to remember that when we're linking these together, we can actually use the -o and rename our output to a nicer thing than just a.out. Same thing. So that's the first part. So everything I just went through talked about how you're doing the separate compilation and doing the header files. And again, just remembering the header files are going to be important when you're breaking up your code and you want to share it between two spots. Now, what is really annoying is I don't think any of us want to type everything that I was just doing again. So going through all of these commands, searching, even being lazy like this of trying to compile it. Like, I don't want to do that every time. It'd be nice to way to have an automated tool to do that, to help us with this build process, especially as it gets bigger. And on Linux and doing stuff with C++, a nice tool to use is actually the make utility. Now what's going to be important for this is basically you're making a new file that has its own syntax that's separate than C++. It's a syntax that the make program understands, and then you can break up to different commands of like what you want to have happen. And you have rules that you can then define, and then make will follow those. So what we're going to be doing shortly is we're going to be making our first make file, and what there is, you always have one file, and it's either called make file with a capital M or make file with a lowercase m. You have to name it that way with no prefixes after that. It is that when you type the command make, it will look in the current directory you're in, and it will look for a file with one of these names right here, and it'll start reading and executing things from it. Now what's important is to understand the structure, and you can go find tutorials and other things about makefiles and get more advanced things and become coding wizards with it, and it can be a really useful tool in the future, and especially your future assignments. But right now when you're coming to it, to read it, is the first thing is that this is going to be the first thing that's going to run, and then these are other rules. And everything has the format of target, so being the name you have for a rule, colon any dependencies. So what to do this command, what's required for other rules to actually match up, and then the command or a list of commands that you actually want to have executed. And what's going to be really important is this spacing you see here is it's an actual tab where you have to hit the tab character. You can't just space in manually with the space bar. You actually have to hit tab to get that to work properly. Now what's important for the breakdown of this one is since this is the first rule that's here, this is the first thing that's going to run, and it's going to look for these dependencies, which really means to see is like, okay, are there files like that that match in the directory? And if it not, it won't go past this. But it's also nice, if you notice that this says main.o, you can see here that we have main.o down here as another target. So it'll know that, hey, these two things match up, main.o. If I don't have that already, well then come down here and then follow these rules to do it, which means it needs a main.cpp and then the g++ minus c, the main, and say running this actual command. So all of these actual steps. So we're really just going to be setting up a make file to automate what we were just doing. So our first step here is I'm going to go through and just clean everything else we had up before. Back to, you can see the original files here, rm test, so we have just the original files we started with before. So now we're going to make the make file. I'm going to use the capital M name for it right now. And I'm going to be lazy once again and just copy and paste this in. And then fix a few things even after copying and pasting it in. So one thing is we've got these rules, you got the space here, but you can see how this command lines up exactly. Well, I have to make sure now that I go in front and I am tabbing it in. So hitting the actual tab character. Add some extra space in between here. So tab, add an extra space, and go tab. Right now, be aware, so again, this tab is the very important thing that you have here in adding some space. And right now, it just has one command, but be aware you can have more commands as long as they follow after this one right here. So even things like any other commands that you can put into the terminal or anything like that, but as long as you actually tab it in. So the idea is you should type this in and make sure that you got everything right. So test prog, colon, the main.o, g++, your main.o, util.o, -o. Now these are all the rules. Now the idea here again is that when it comes in, it's going to see that this is the first target that's right here, so it's going to run it within the file. It knows that it needs main.o. And so it's just going to run this command here by default, and it won't jump to these unless there's something that's actually triggering them to actually run. So what it will do is it'll see, okay, it needs main.o and util.o, and it'll see that, oh, hey, that's not in the actual current directory. Right there. And so then it'll see, oh, there's a rule for it. So it'll know, okay, this one needs main.cpp. Okay, that file is there, so then it'll go on and actually compile this one. Same with the util.o. It'll see that there's a util.cpp and it'll compile this and make it, which then will result in the .o's, and those will finish. And then this will see, hey, these dependencies are there, so it can go on and then go and run this command for us. So now I'll make sure that I've got this saved. I got no extra tabs or anything else. Make sure we got it all good here. We got our files. Now if I type make, again it's going to look and find the make file right here and start running that first command. And you'll see it echoing out the commands that it actually does. Okay. You can see here that it got a little error, and that's just an error from my typing. So I did not have the space over here to actually properly have it to rename the test prog. Type make again. That was just another error here from copying and pasting. So I just had to make sure that there weren't any other weird characters there. Do our make one last final time. And there we go. You can see it echoing out all the commands. That new main.o did this one, util.o did this one, and then finally ran this command right here. And then we've got our test program. And hello world. Now what's nice about this is that it'll only need to recompile. So I can type make again. And it knows that everything's up to date because it's also going to check for your dependencies if there's been any changes to the file, so if they've been modified. So now when we do this, it's not making any changes right here. It's not recompiling because we haven't actually changed the file itself. So if we open up our main.cpp, and just make a change, anything else here, so even a space like this, right here, we save it. The system's going to know that that file has been modified in some way, so the make will actually detect and recompile just that one component of it. So you can even see here, it did the main.cpp and then relinked it together, but it did not do the actual test util.o. Why? Because the util file wasn't updated properly. Now, what we can also do is that, okay, well, if we remove the .o file, you can see we can now go and recompile it. And same thing this time now, it'll just compile the .util.cpp and then link everything together. So you notice we don't have to keep repeating these commands, and as we add more and more files, this can become easier, and we can also start making more advanced make files. And what's also nice is that by default, the make, so let's open up your make file again. Here, so we open up the make file. Right here is that we have these targets, and this will be the default one, but these targets you have here are actually also commands you can give make to say, hey, just run that one command. So let's say again, we go remove the util.o. Talking and typing never works for me. We don't have that. We can now go make and just tell it just to compile the .o. Don't link anything else together. Just run that one rule that we have here and whatever comes into it. Let's go to make. So we've compiled and we've got our .o back, but it hasn't recompiled and linked everything together. So it's a way for you to set up different commands that sometimes that we can use to do utility extra things for you and extra commands that you don't want to type everything out while you're coding and compiling and bringing it all together. Now, for example, let's say we wanted to add a command in to clean up and remove any .o files and just get everything and any like compiled names for the actual program. So what I can do here is after this last command, make sure that I'm down here. I can make a new command. I'm going to call this clean. I'm going to say it needs no dependencies, so it doesn't need to wait or know about any other files. It just can go right ahead and start doing any commands we want. I've hit tab to move one space in to start doing our commands. And now I can do things like, okay, well, what if we do rm rf and we just do star.o any .o files. Any of the backup tilde files, and the executable itself. So I can save this. We don't have anything in here for right now, but let's say I go do some make. I've got these .o files right here, the test prog, everything else that could be good. And let's say I just want to refresh and get rid of everything that was compiled because something weird is going on. So now I can go make and type clean. Runs those 3 programs for us, and you can see, hey, look, it's all gone. So we have our utility thing. We could even modify our make file so that we're like, hey, I want it to make sure that everything is removed right now. So I can have the rest of these here, but what I could do is I could actually put the clean command first as a dependency. Forgot a flag up here. Right there. So now when I do it, it'll do a clean first to remove everything, and then it'll compile. So this is the way if we want it to be a fresh, fully cleaned, and like compilation every single time, and making sure that everything was compiled properly. So that's only if you want to, but it's a way that you can do extra commands and keep building upon your actual make files. Okay. Now, the next thing is to realize is that when you're running these make files, it's not going to use any aliases or anything else that you have actually set up in your own terminal shell, because when make runs, it creates its own new shell to run in. And so any of the other dependencies or anything that you're actually needed, you need to actually add them in. So if you had cases like this that you were using for 1631 or an earlier course, or whatever course you were actually in, then you need to use those. So we can go add those in ourselves. Now, you'll notice this is repeating stuff a lot, and there is going to be a way that you can make your own variables to add on top of this to make your compilation a lot, like your program a lot more advanced, maybe making a generic make file. So let's, right here, do a make clean. This would just be the fun of apparently me copying and pasting stuff, because it adds a different dash in based upon my keyboard. So that's just my case why it wasn't working. Save it there. Make clean. Make. And there we go. Your handy dandy, boom, hello world. You could even get crazier with this, as if say you want to compile and run it right after compiling it every single time. You could make another rule. Let's see if this works. I'm just doing it right here. Is build run. And we will say it needs dependency of test prog, so the whole program is actually done. So we will do a clean, then compile the actual program, type it right here, and then we can just get it to actually run the program at the same time. So compiling run. So if you're doing this a lot. You get used to it when you're just test programming and you're compiling and then testing it automatically afterwards. You could maybe add in another rule to do this for you. Let's hope this works. Yay! You can see removed, clean, compiled everything, ran our program, and we have it here. So I could go and do my editing and then just come back and hit make build run to recompile and automatically run it and maybe save myself some time or keys. So you can keep getting creative with this as you want. Look up some more commands of actual make, because there's way more to this so that you can keep. Now what you can go do now is go on to the actual extra handout if you would like that was given out in lecture for this and do a few more, but I'm going to demo a few of these now so you can add a few extra features into this. Now one example we can add in is adding variables into your make file, because what if we had all these flags here and we don't want to really copy and paste them every single time? What if we wanted to actually make a variable and just set it once and then use that down here? So what we could do is make a new variable, whatever name we want to call it, but let's say we'll just call it CPP flags for convention. We have up here. We can then copy those flags that we had here before as tag, keeping it all on one line, not separating this from right here. And then we can replace it later on down here with the actual variable. You can see it here. So we have the variable here to actually access it in the syntax that make uses, which is not CPP, so not your actual C++. You have the money sign and an open and closing round bracket around the variable. So we can do that again down here. Okay. We'll do another make build run. There we go. Everything's working. We can see that variable being used. We can see it being replaced. You can also start adding in documentation. So again, remember this variable here, everything has to be on one line. You can't have it on separate lines or this won't actually work. Right now, we can start adding in documentation if you want, which is just using the hash symbol. Right there, you can see it goes red. We can type whatever we want, and that is actually just your commenting. So we can even do nicer formatting, maybe add in some lines to make it easily readable in between from your top to your bottom, whatever you would want, maybe some explanation of what's going on. Still all works. Okay. So that's your basic step. Now I do suggest you go take a look at that extra handout when you get a chance and demo and start learning some of the advanced features of what you can do with makefiles to make these even more useful for your future endeavors. Other than that, I hope all of you are doing great, and I want you to all know that you're awesome. If you don't think you're awesome, I disagree with you. I'm the teacher, I am correct, and you are awesome. Go on and continue having a great day and learning about C++ and getting closer to graduating.